Hello chaps. Quite a lot's happened since last time, so let me have a quick look and see what we've done. First of all, we've ditched this thing. This is the Quad ESC controller and it is absolutely pants. Don't use it. Mine's blown up, smoke came out of it, I don't like it. It's also got a program inside that shuts down when the battery gets low. Not very useful for a quadcopter. So what have we done? We've changed to 4 Simon K ESCs, there they are. We're soldering them up at the moment and we have a connection board at the top. This thing here, which is the thing you solder on for the high power connectors. No problem. What else have we got? We've had a redo of the base. Where's the base unit? Here's the base unit. And we've got an A+ Raspberry Pi in there, which works quite nicely. And the Raspberry Pi manages the LED lights and it manages the camera, which is on the front here. You can see the ribbon cable going down there. Raspberry Pi does the lights and it does the Raspberry Pi camera in the front. Underneath you've got the sensor as well that tells you how far off the ground you are. So far that data only stays with the Pi, and the Pi isn't connected to the Arducopter at all. Flying controls are all done by this Arducopter unit here, Arduino, which is all very well documented on the web. So what else is new? Not a lot really. Suppose I better get it going. Here we go then. Hi folks, we're going to take a look at the Raspberry Pi Arducopter, Dobby the drone. We're going to have a look at the two halves before we put them together. So let's see what we've got. And yes, that was a selfie. Right, what have we got? This is the base of the drone. Wooden undercarriage with some 15mm pipe insulators there to give me a soft landing for when I crash it. This is the core of the flight control, which is the Arducopter. It's an Arduino based copter control unit. It's got gyros built in, everything to look after it and keep it the right way up. It's got plugs for GPS and everything like that. Also we have a peripherals board that I built, which has an integrated circuit in down here that drives the smaller LEDs and 2 TIP 120 Darlington pair transistors that drive the high power transistors, the high power LEDs, sorry. And the high power LEDs are, just turn it round, the 2 headlamps at the front, which are about 1 watt each, or should be, and underneath the 2 landing lights you can see there. Underneath also there's the ultrasonic range sensor, which is connected to the Pi, and batteries underneath as well. What else is underneath? Battery sensors down there, that'll connect in, that's completely separate system, just gives a beeping noise out when the battery runs low. So that's the underside of the thing. Let's look at the top again. We've looked at the peripherals board. We also have here, that's new this week, a switch that I've put on. This is a switch that will power on the Pi, because I don't want the Pi to be powered off on its own because it needs to be shut down properly. The Arducopter module is a microcontroller. It doesn't really matter so much if it gets its power cut, as long as it's not cut during the flight. Right, Raspberry Pi. We've switched to an A+ model. Lower power, lower weight. It's got Wi-Fi on, so we might do FPV, first person view, using the Wi-Fi, maybe. And the 40-pin connector is connected across to the peripherals board, to the LED drivers, and these 2 things here, which are switches. That's a switch there. One can be for shutdown, one can be maybe for start up the LEDs or something like that, or start the video. So there we go, there's the base. Raspberry Pi does the camera, which is down the front here, 5 megapixel camera, and it does all the LEDs, the flashing lights, and it does the range sensor to the ground, and the Arducopter does flight control. They are 2 separate systems, they are not interconnected yet, but they will be one day. Right, next bit. this is the top. Top has been rebuilt because the last Quad ESC didn't do very well. Some smoke came out of it. So we've replaced the Quad ESC with these 4 Simon K 30 amp ESCs, electronic speed controllers, connected in the middle by this high current distribution board. Soldering's reasonable, and a 30 watt soldering iron will connect them all quite happily together. So there we go, it's a simple distribution, just connects plus and minus to each of the ESCs and takes it from the battery. So battery connectors out the side. We're going to be able to connect and disconnect the battery from the side of the drone. Right, what else do we need to know about this? LEDs, blue LED on each leg on the top, yellow LED underneath each leg. So it's got 4 blues, 4 yellows, so there's 4 whites underneath in the base frame, and it's got 2 headlamps and 2 landing lights. That's a lot of lights really, a bit more like a Christmas tree. Right, motors connected up for now, a bit messy. We're going to be changing those 3 connectors if the thing spins the wrong way around. And if the motor spins the wrong way around, we're quite simply just going to change any 2 of these 3 connectors in there here, and then it will change direction. So we need to know which direction it should be going in, and we'll be looking at the propeller orientation as well. At the end of the top here we've got the GPS receiver, which connects via the little ribbon cables to the Arducopter. We've got the COM5 remote serial port that connects to the PC via wireless, not wireless, radio, 933 megs I think. That connects to the Arducopter as well. The radio, 2.4 gigs radio receiver is going to connect to the Arducopter. Those are the 3 things that connect to the Arducopter. And then we've got the power distribution, we've talked about that already. LEDs on the top and the motors at each corner. It's loosely wired at the moment because we are going to change these around, I expect, and then we'll tie wrap them to the frame, make it a bit tidier. Underneath the top half of the frame, an awful lot of wires. Right, what have we got? Let's look at this in perspective, shall we? We have got the GPS connections down here. We've got the LED power connections down here that go to the power distribution board for the LEDs. These are the dew point 0.1 connector with the heat shrink insulation over the top of them. The dew point little connector things like this thing down here, they didn't work so well on the single connectors, so we've just used heat shrink on there. It works very nicely indeed. Okay, right, so we've got the LED to connect up, we've got the telemetry to connect up, that's the COM5 connector, we've got the sat-nav connector to connect up, GPS, sorry. We've got cables here that come from the 2.4 gig radio receiver that will go to the Arducopter. Now we've got 4 control ribbon cables that come from the ESCs, and they're quite important. The ESC, where's the ones for the front ones? They're out here. Oops, my bad. There we go, there. One here and one there. There we go. Right, so out of the, where the ESC comes out, we have got a cable with a red, white and black on it. Black is the earth, red is +5 volts fed from each individual ESC, and the white is the signal, that's the pulse width modulation PWM signal to the ESC to start the motor up. So for each of them we connect in, they connect into the Arducopter flight control, but we're going to use the 5 volt power only on one of them. This one is going to power the Arducopter, it's got the middle red connected. The other ones have the middle red stripped out. That one's stripped out, that one's stripped out, and this one's stripped out here, but where we've stripped it out, where's it gone? There we go. 3 wires out. The last one has got a dew point socket on the end of it, and that's going to power the Pi, and it will power the peripherals board up the LEDs. Right, enough said. Time to plug it all together. God, what a mess.